Greetings and welcome, friends. Mr. Waddy and fellow geometricians here, or like geometricians in the making, and it's Valentine's Day, and all of my students have fallen in love with proofs. It was like this thing where like they hated them at first, but then like they're all like, "What proofs? You were there the whole time?" I don't know. I've kind of used this joke before, but it's fine. That's kind of how all my jokes are. So hooray! Let's see. So exercise 3, copy and complete. Copying is done. You're welcome. Let's see. I think my lines are right. It just seemed like that was extra solid a moment ago. Oh dear, I just like alt-tabbed out all my stuff somehow. Anyways, given... Oh dear. Is my like alt button activated? Wow, this video is great. So if you were absent for some reason, feel free to write this down. I do not consider that cheating. I consider it an opportunity to learn. So let's see. PQ is equal to RS. What is that reason? Given. Man. You're supposed to be yellow. Given. That's the best reason. PQ plus QR. So PQ plus QR. That's this length. Is equal to RS. S plus QR? Boy, that's... Wait a minute. How do they get there already? Oh, look at this. They went from here to here by adding QR to both sides. So what property would justify that, do you think? Yeah, I was gonna say, I was like, man, it looks like they jumped the gun on like some segment addition or something. But that's the addition property of equality. And when we end up writing our proofs later, we're going to try to want to make sure that like sequentially each step makes sense as much as possible. All right, so PQ plus QR is equal to RS plus QR. Segment addition postulate here, let's see if I can color code this. They said QS, that's this one, is equal to the sum of those two. So if I have another seg-add post being applied, I'm guessing it's going to be this one. Would probably be the most helpful one, right? So I could say that, let's see if I can match the order as well. I'll call that, yeah, PQ plus QR is equal to PR, right? So segment addition postulate, the sum of the two smaller segments is equal to the larger segment. And then I could combine those, and how could I have gotten to this point? All right. PR is this. PR is equal to this, which is equal to that, which is equal to this, and therefore PR is equal to QS. That looks like transitive to me. That's a train of equality. So trans prop equal. There we go. All right. There we are. Name the property that the statement illustrates. Question, comment, observation? Are you going to give me an answer? Reflexive. Man, that's crazy. Man. Reflexive property of, technically of angle congruence. But eventually I'm just going to be like, yeah, reflexive. Come on. Come on. All right, how about a 9, the not third 7, as it's frequently called. Yeah, that looks like symmetric property of segment congruence. Yeah, we learned all sorts of crazy names when you were gone, Ryan. All sorts of crazy names. Oh, here's a proof. 13. All right, let's see how well I can do this. I don't know, friends. I don't know what we're gonna do. All right. So, GFH is congruent to GFH. Those are, oh, GHF. Let me label that in the picture even. So GFH, this angle right here, is congruent to angle GHF, this angle right there. Starting with your given is usually a great idea. So I'm going to write that angle GFH is congruent to angle GHF. And labeling it in your sketch is a good idea as well. And the reason that's true is given. So if we, on our test, happen to have a write your own proof, which you won't, besides like algebraic reasoning kind, you should at least start with your given. That's a good place to start. They want us to prove that EFG, this kind of exterior angle will be the name for that one in a moment, is supplementary to GHF. Okay, so they want us to compare it to this one eventually. So I think I've got a general strat here. I think I could say that it's supplementary with GFH. You guys think so? Angle EFG is sup with angle GFH. There we are. Because these two form a straight angle. Wait, have we done linear pair postulate yet? We haven't, have we? Man, I was just gonna like super shortcut for us. Let's see. What is the... Are they going to make me go through form a linear pair? All right. Yeah. I'm just going to... There's basically two reasons here. These two angles form a linear pair, right? Because together they make a straight angle. And then linear pairs are supplementary. I'm just going to call that linear pair postulate. I just combined two things into one. I'm sorry. My bad. It's okay, though. We're cool. And if those two things are supplementary, then that would, by definition of supplementary, say that measure of angle EFG plus the measure of angle GFH is what? What do those add to? 180, right, by def of sup. And because these two angles are congruent, I'm seeing an opportunity to like pull this in here in a moment. If those angles are congruent, what could you say about their measures? Yeah, those measures are equal, so measure of angle GFH is not congruent, but equal to measure of angle GHF, right? That is def of Kong of the angles variety, technically. And let's see. I'm thinking I can make a statement combining these two. I'm thinking I'm going to be able to do this. And do you guys see how that would be helpful in working towards this goal? Yeah? Methinks. So yeah, kind of like planning out my proof is going to take, you know, some time for you guys to get used to as well. But I'm going to say measure of angle FG plus the measure of angle substitute GHF equals 180. That's subs prop. Technically of equality. I'll write it down just for good measure. And because those add to 180, I believe I can end with my proven statement. Question, comment? Yeah. Oh, yeah, I'll actually ask that question again in a moment. I can help you. Not present yet. Sorry. Yeah. Let's see. And GHF are supplementary. And the reason that's true is by definition of supplementary. Def of sup, which notice I used earlier. Here I used it to go from knowing supplementary to that their angles add to 180. And here I'm using it to know that these angles add to 180 to saying that they are supplementary. So definitions, remember, are biconditional statements. I can use those in two different directions. So I end up taking a little bit of a shortcut there. My bad. I'm having a hard time pretending like I don't know the things I know. My bad. Let's see. I think I've got one more for us. Here we are. 23. Solve for x using the given information, justify each step. So I've got, let's start with our gimmies. QR is congruent to PQ. Reason given, because someone told me so. Question book, you just told me in question 23 that it's true, so I'm saying it's true. Let's label that on our sketch even. So QR is this one, and it's congruent to PQ. This one. All right. True story. And then RS is congruent to PQ. All right. So this one is congruent to PQ. And how would I be able to know that? Yeah, so this is given. I'll just write ditto. And then you guys are saying that you think QR is going to be congruent to RS. And that's true by the transitive property of congruence. Segments, technically, right? But someday I'll just be like, you guys will say transitive, I'll say transitive. We'll all know what each other is saying. It'll be like, transitive. And we'll all know. Now, if those two things are congruent, then that means that QR equals RS. How do I go from that to that? That's def of Kong. And now I can, I've got Ryan saying that, let's see, QR 2x plus 5, I like it, equals 10 minus 3x. Does anyone know how I could go from this one to this one? Yeah, I'm technically substituting is what's happening there. All right, these were values that represented those measures, and so I'm substituting those values in for those measures. And now it's just going to be algebra, friends. Algebro. Let's see, I would write, let's say I have 5x plus 5 equals 10. How could I have gotten from there to there? I added 3x to both. Oh, sorry, I forgot to write subs. Subs prop equal. And then you're right, this is the addition property of equality. Then I could have had 5x equals 5. Using subtraction property of equality. And then I could have x equals 1. Division property of equality. See, we're super good with the algebra. It's just going to take a little while to acclimate to the geometry. What was I trying to prove? Solve for x. Good. I'm glad they didn't ask me to like solve for QR, because that would then be like another substitution and a lot of my time. So thanks for watching, internet friends. Have a great day.